Hi, just gonna get started in 4 minutes. By the way, can you guys hear me well? Okay, thank you. Thanks for the confirmation. Two more minutes. We'll let everyone join and then we can start. Yeah, we'll start now. So as always, this is week two. This lesson is on congruency of triangles. By the way, did anyone have any questions on the homework? Except the last two problems. The last two problems are kind of extensions, but if you had any knowledge of the content that wasn't covered in, like, any knowledge of future content, then that was kind of extensions for you guys to do. Did anyone have any questions or like problems that you want me to go over, or you're fine? Okay. So today's lesson on congruency. Sorry. So what do you mean? What do I mean by when I say congruency, right? Basically, a very informal definition, but I guess a sort of intuitive one is if I have two triangles, say like, or any two figures, if I even have, if I say if I had circles, then that would be fine as well. But since we are focusing on triangles today, let's do triangles. So if I have, yeah, yeah. So as one of you said, they're exactly the same. But here's a here's a more informal definition. Uh, for people that are unfamiliar with this topic. So basically, if I have two triangles ABC and XYZ, congruency is basically like if I like do anything with the triangle, right? I like slide it, or I spin it, or I flip it, or do anything with it, right? These two triangles have to if you put these two triangles on top of each other, right? These two triangles would fit exactly, like there would be no discrepancies in between these two triangles when you put them together. So basically if I transpose XYZ onto ABC, and I like say I had two cardboard triangles ABC and XYZ, right? And I put them both like together, or like put one on top of the other, it would fit exactly the same. That's what congruency means. And for that to happen, what has to be equal? The sides have to be equal, obviously, because if the sides weren't equal, then there's no way you would have even put the two triangles together and like fit them exactly in the first place. And the angles, like these angles between the sides have to be equal, right? So like corresponding side, the like say angle ABC in this figure, angle ABC had to be equal to angle XYZ, and then blah, and then angle YXZ has to be equal to angle BSC, and etc. But the point I'm trying to make is if you put these two cardboard triangles, right, on top of each other, they would be exactly the same. So for that to happen, the angles have to be equal, and so does the sides. So there are a few types of congruence theorems that I want to go over. Let me keep this. First one is called sorry. First one is called SAS. So let me write it here, SAS, right? And this is basically where you have two triangles like these, like this, and basically in the problem, right? Side, yeah. SAS stands for side angle side. For those of you who didn't know, so basically, say I had the same example, right? A, B, C, and X, Y, and Z, right? Basically, what this is, by the way, congruence theorems are basically based upon what you're given in the problem about those two triangles, right? So basically, if you're given that, uh, say say AB equals to XY, and AC equals to XZ, and the angles between them, which is the angle between AB and AC is angle BAC. So angle BAC equals angle uh XYZ, or sorry, angle YXZ. Then these two triangles are congruent to each other based on the side angle side congruence theorem. Basically, why it's called side angle side now, I think it's pretty obvious for you guys, but if not, it's basically side angles side. So basically two sides. Basically the congruence theorem is saying if there are two sides that are, so like two corresponding sides, it has to be corresponding. So AB has to correspond with XY. AB can't be equal to YZ. That makes that like, even if it was equal, that would have no effect on the congruency of these two triangles. For these two triangles to be congruent, uh it always have to, the sides and the angles always have to be corresponding. So AB is corresponding with XY, AC has to correspond with XZ, or you could have done BC and YZ, but I chose not to here. And and then the angle between those two sides, between those two corresponding sides that are equal, have to be the same. Then these two triangles satisfy the side angle side congruency theorem. So side, and then the angle between them, and then the side. So that's why the theorem is called SAS congruency. Does that make sense? Okay, so if that makes sense, let's try a problem. Here. So let's try a problem. Let's go here, and so the problem is basically saying if you had something like this, sorry, if you had something like this, and then something like this, say, and then this is this is equal to this oh, let me x, so x w y, and then here's vz, and if xw is 7, xy is 3, and then wy is 8, and then it's given that yz is 5, yz here, and don't mix that up with xz is not equal to 5, it's yz equals 5, and then xv is 7. So what they want you to find is vz, and I'll give you guys like 5 minutes. Try to figure out what VZ is. By the way, is everyone clear with the problem, or do you want further explanations or clarifications? Any clarifications, I'm happy to give. No, everyone's fine. Okay, so let's try 5 minutes, and then we can discuss. By the way, a side note, guys, the diagram is not to scale. So don't think that since triangle XVZ is bigger than triangle the triangle WXY, like you see how in the picture triangle XVZ is bigger than triangle WXY, right? Don't think that that's intent like that. The diagram is not to scale, so don't think the sidelines have to be that way as well. So maybe 1 more minute since this problem is not too bad. We'll discuss it. whatever your time is, that dot 15. Uh, so let's go over it. Since this problem was not too big, not too hard to see, I'll just go through it myself. So basically, if you guys notice here, you use the side angle side congruence, right? So you're given that wx, sorry, you're given that wx is equal to 7, and you're given that xv equals 7, right? These are so you can just look at the diagram, and this is what it says. So this is one pair of one this is a useful piece of information we need to solve the problem. The other thing is xz equals 8. You could have just added the line segments xy plus yz, and that would have given you x equals 8, and then wy equals 8, right? And then the other piece of information we need is these two angles being equal. So these two. So angle xwy equals angle vxz. You guys notice something between wx, wy, and this angle being equal? It's basically that you have to use the side angle side congruence, because wy because wy equals wy and wx, sorry, wy and xz are both equal to each other, are both congruent to each other. Wx equals 7, and so does xv. Sorry, this is not a z, this is a 7. So these two lines are equal to each other as well. And then these two angles, angle xwy and vxz, and since the two corresponding sides, which are wy and wx, since these two corresponding sides are equal to each other, and then since the angle between them is equal to each other as well, you see that xy equals 3 here. Xy is going to correspond with vz, so vz is just 3. You use side angle side congruence here, and you get vz equals 3. Is everyone fine with that, or does anyone need more explanation? You can give me a thumbs up in the Zoom chat. Everyone good? Okay. Now I'm just going to take that as yes. So we'll go over to the next type of congruence. The next type of congruence is SSS. This stands for side congruence, right? Basically, what you can get from the name is that if I have two triangles again, ABC and XYZ, right? If I have two triangles like these, and in the problem statement, if it says that the corresponding sides AB equals XY, BC equals YZ, and AC equals XZ, then the triangles are going to be congruent to each other by this congruence theorem, side congruence theorem. So basically, if these three side lengths are given as equal, then everything about the triangle is going to be congruent or like equal to each other. Like the angles, like all the angles are going to be equal to each other. Also, this is a notation thing, but if I want to say a triangle is congruent to some other triangle, I denote it as I write it like this. So you say angle ABC, triangle ABC is congruent to triangle XYZ. This is called the congruency symbol. So just keep that in mind. And also, it's very important to emphasize that the corresponding sides and the corresponding angles have to satisfy side angle side or side or whatever congruence I'm teaching you. If that's not the case, you cannot apply any of these congruence theorems. Like you, like a lot of questions are gonna be just based on this, and if you get the problem wrong, because it's kind of because the problem writers write the problem that way to like trick you or something, but basically the main trap is like someone says someone sees that, oh, AB equals 3 and so does YZ. Oh, I'm just gonna say that this is and say like basically this is a very common trap. So the problem says that AB equals YZ, and then, or let's write it like this. AB equals XY, and then AC equals 4, and so does XZ. But they give some other angle, right? They say this angle is equal to this angle. If you want to use side angle side, you have to make sure that the angle between them are equal to each other. You cannot say that angle ABC equals angle XYZ, and thus I'm going to use the side angle side congruence. It doesn't work that way, because that's not what the theorem says. So this is a very common mistake. Make sure you don't uh apply that, or make sure you don't make that mistake. Is everyone clear on side congruence? Just give me a thumbs up in the Zoom reactions. Everyone okay? Okay, so we'll just go over a problem now. The problem goes like this. It's so I have something like this, and then this is A, this is B, this is C, this is D, and then I draw a diagonal like this. By the way, this is just a side note. We'll be doing this more, but when you when you when you connect a line between two opposite sides of a four-sided figure or quadrilateral, like a four-sided figure is called a quadrilateral for those of you that didn't know. If you connect if you draw a line between two opposite vertices, that's a diagonal. It's called diagonal, by the way. So here line AC is a diagonal. Let me just write it here. No, yeah, anyway, so the problem, so this is the required information, and then the problem asks you to find angle MLN. We'll go for 2 minutes here, since This problem is a direct application. Find angle. Oh, sorry, not angle. The problem asks you to find angle BSC. So find angle BSC. And we'll go for 2 minutes. So we'll discuss it. So we'll go with the solution now. This was fairly easy to see, but for those of you that so basically you can break this quadrilateral into two triangles, right? Triangle ABC and triangle ADC. So you see that line AD equals line BC. You see that line DC equals line AB, and then you see that this is just equal to itself, right? So AC equals AC, pretty obvious. So you see that these two triangles meet side congruence. So because all the side lengths, all the corresponding side lengths of these two triangles are equal to each other. So they meet the side congruence, and then basically if this angle is equal to 25 degrees, sorry, if this angle is equal to 25 degrees, we see that this is between DC and AC, right? So we see that DC corresponds to AB, right? So DC corresponds to AB, and then AC is just equal to itself. So we see that this angle here also is equal to 25 degrees, which is what we were asked to find here. So this is just 25 degrees. Everyone got it? Or do I need to explain further? Everyone good, right? Or you can just give me a thumbs up in the reactions. Okay. Uh, okay. So we'll move on. So we'll cover two more types of congruences. One of them is called ASA congruence. This stands for angle side angle. Angle side angle congruence. Basically what this says is angle side angle basically says that if you have two triangles, again say ABC and XYZ, ABC and XYZ. If you have two triangles like these, like this again, and if I say that this angle, sorry, if I say that this angle is equal to this angle, and this angle is equal to this angle, right? So angle ABC is equal to angle XYZ, and angle ACB is equal to angle XZY. And then if I say that the side that these two angles lie on, which is BC and YZ, right? These two angles lie on one side, which is like BC, right? Like the common side that they lie down is BC. So BC here is equal to YZ here, right? Because both of these angles lie on BC, and both of these angles lie on BC, and both of these angles lie on YZ. Both of these angles lie on YZ, yeah. So here you can use the ASA congruence. These two triangles satisfy the ASA congruence. ASA stands for angle, side, angle. This sounds similar to side, angle, side. But basically it's reversed now. So it's angle, side, angle. So you have two side angles, and if those two angles are equal to each other, like angle ABC equal angle XYZ, and then angle XZY equals angle ACB, and then the sides between them, right, which is BC and YZ, if the side between them is equal to each other, which is BC equals YZ, then these two triangles satisfy angle side angle congruence. Does that make sense? Yeah. Okay, so I'm just gonna assume that as a yes. So here is a more conceptual question to see if you guys actually understand the concept. If I have two triangles like this, which is like say X, Y, Z, right? And if I have something like this, which is like A, C, B, right? If I have something like that, right? Yeah, actually let's relabel the sides. So so A, B, C, right? And then X, Y, yeah. Okay, so if we have something like this, and then we say that, or yeah, so if we have something like this, and then we say that this angle is equal to 60 degrees maybe, and this angle is equal to 30 degrees or 20 degrees. Or yes, let's say this angle is equal to 40 degrees, right? And then again, if I say that this angle is equal to 60 degrees, and this angle is equal to 40 degrees, and if this says 5, and this says 5, does can we conclude like can we say that triangle ABC or XYZ is uh is congruent to triangle ABC? Can we say that this is a true statement? We will like let's discuss in 1 minute, so 4:30, so N34. Okay, so let's go over it. We actually can't deduce that these two triangles are congruent to each other because we can, if we can figure out the other side of the triangle, right? We can figure out the other angle of the triangle, remembering uh what we covered last week. So what's angle? Sorry, what's angle? Wait, I think the screen froze. Yeah, okay. What's an angle XYZ here? Sorry, I think the screen froze. Yeah, so what's angle XYZ here? Remembering what we covered last class, what is that? It's 80, right? Because if you guys remember the things we covered last class, the sum of the angles in a triangle is 180 degrees. So whatever was given is the sum of the angles already given in the triangle was 60 plus 40, 100, right? So if you subtracted that from the sum of the angles, that was sum of the angles in a triangle, that's 80 degrees. And similarly, this is 80 degrees. Now is it clear why you can't deduce that these triangles are similar to each other, or these two triangles are congruent to each other? It's because you can't use ASA congruence here. You can't use that because it's true, because because you have two different angles here. Even though one of them is equal to each other, like even though AD is equal to AD here, this this angle is equal to, sorry, even though this angle is equal even though this angle is equal to this angle here, you can't say that these two triangles satisfy ASA because the other angle is 40 and one of them is 40 and the other one is 60. So you can't deduce that these two triangles are congruent. Does that make sense? Okay, I'm just gonna take that as a yes. So uh we'll cover one more type of congruence, which is which is ASA. Uh, yeah, sorry, AAS. Uh, what do I mean by that? It stands for angle, side, and it sounds exactly like it sounds exactly as what is written. It's basically, if I have two triangles again, say like ABC and XYZ, right? If I have something like this, and then I have two angles that are equal to each other, so like this angle is equal to this angle, and this angle is equal to this angle, right? And then if I have angle, and then if I have the side, if I have a side that is opposite, if I have, say, this is equal to 5 and this is equal to 5, like if I have, say, sorry, this is too specific. If I have this side equals this side, then we can automatically say that these two triangles are congruent. So like triangle ABC is congruent to triangle XYZ based on a congruence theorem called AS, angle side. It's basically that uh it's basically that two angles and the side up and this, like these two angles are like, for AS to happen, you have to have two angles that are equal to each other in a triangle, and the side opposite to one of those angles that are equal to each other. So what I mean by that is you have angle ABC equals angle XYZ in this picture here, right? So if I said that line AC is equal to line XZ, then that would work because the side opposite to uh, a corresponding equal angle, angle ABC and angle XYZ, if those two corresponding sides are equal, then the congruence would hold. This is symmetric, by the way. So if I said that, if instead of AC and XZ, if I said that AB and XY are equal, same thing. Angle side would hold as long as this side here is opposite to one of the corresponding equal angles. So like angle ACB. So for this theorem to hold here, we would have two possible cases here. Either the side is opposite to angle ABC, so this side over here, or the side is opposite to angle ACB, so this side over here. Then the congruence theorem would hold. Does that make sense with everybody? Okay, if that makes sense, then I guess we'll. So just remember that the side has to be opposite to one of the corresponding equal angles. Say in this example, right? Say in this example, if I said that line BC, sorry, if I said that line BC, if I said that line BC is congruent to line YZ, that wouldn't work because it's not opposite to an angle that we know to be equal. Angle ABC, for this to work, angle BAC, so angle BAC would have to be equal to angle YXC. So like these two angles. But in the statement, that's not given. It's only that angle ABC is equal to angle XYZ and angle ACB is equal to angle XZY. Nowhere is it given that angle BAC and angle YXZ are equal. So just keep that in mind when you do when you do the problem. So I guess we'll go on to an example problem now. Um, so this is more of a conceptual question. If I have something like this, so this is a B, this is A, this is M, this is C, this is D, and line BA is parallel to line CD, then, and also M is midpoint. M is the midpoint of AC. So like M breaks AC into two equal parts. So like AM is equal to MC. So AM equals MC. Is it necessarily true that M must also be the midpoint of BD? BD meaning this line here. Uh yes or no. And I'll give you guys like 3 minutes to figure the solution out. Now, one more minute and then we'll discuss the solution. Okay, so we'll discuss the solution. The answer is yes. You could have concluded if triangle ABM is congruent to triangle CMD. And the reason you can do that is something I gave earlier. AM is equal to MC because M is the midpoint, right? And then since since it's given that these two lines are parallel, angle C must be equal to angle A, and angle B must be equal to angle D. If that's not clear. So this is parallel, and then this must be equal to this. And then I think it's fairly easy to see why this holds, because now it's given that AM is equal to MC, and then you can basically just use angle side, because you have two angles. So you have this angle and you have this angle, and you have and you also have the fact that a side line AM is opposite to angle ABM, and since angle ABM is equal to angle CDM, and AM is opposite to MC, you automatically just use AAS, and you get that these two angles are congruent. These two triangles are congruent, and if these two triangles are congruent, this means that BM equals MD. Since the BM is the corresponding side of MD, and that automatically means that M is the midpoint of B. Midpoint of BD. Does that make sense to everybody? If there are any questions, I'm happy to answer. Yep, everyone good? Okay. Okay, so now we'll go over some types of triangles. So if I have something like this, if I have triangle ABC, and if these two sides are equal, does anyone know what type of triangle that's called? Anyone know that? Yeah, it's called an isosceles triangle. I hope I spelled that right. Isosceles, yeah. Okay. So if you have basically what this type of triangle means is that if you have an isosceles triangle, and if AB, and you have to have two sides that are equal to each other, then both of these angles are gonna be equal to each other. So these are gonna be congruent angles. So angle ABC is equal to angle ACB. Does that make sense? So this is a type of isosceles triangle. And if you want me to prove that these two angles are equal, these two angles are actually in fact equal in an isosceles triangle, here's the proof. Basically, the proof goes this way. It's that let me redraw the triangle. So let me redraw the triangle. You have something like this, and A, B, C, right? And this and AB equals BC, AB equals AC. So the trick to this proof is you draw a perpendicular from A to line BC. So you draw a perpendicular from A to BC. And does anyone remember from our first class what that does in terms of angles? Anyone remember what that does to our angles? Or what that does to a specific type of angle? What does dropping a perpendicular mean?
It's a right angle.
Yeah, whoever said that, ZG, is this
Yeah.
yeah, okay. Yeah, that's right. Yeah. So as ZG mentioned here, this these two are right angles. So angle A, so let's say this is M, right? Angle AMB, angle AMB, angle AMC is right. And then since you're already given this is right, so these two are very obviously equal to each other. And then you're given that since it's a perpendicular, uh since then MB equals MC, because if you draw a perpendicular in an isosceles triangle, then both sides are equal, right? And then since AM equals AM, right? AM equals AM. What type of congruence is this? If AM equals AM, MB equals MC, and the angles between them are equal? It's called side angle side. Yeah, side angle side. And by this congruence theorem, you can say that triangle ABM and triangle ACM are both congruent to each other. And if that's the case, then angle ABC and ABM and angle ACM are equal to each other. And that's why in an isosceles triangle, the two angles opposite to the two congruent sides are equal to each other. Yeah? Yeah.
Can we also prove it by the Pythagorean theorem? Because if we split the base by half, then let's say half of the base is x,
Yeah.
and the height is the same,
Mm-hmm.
then x squared multiplied by, let's say the height is y, plus I squared is equal to the side we want, z squared, and
Mm-hmm.
z squared is the same. So so in the isosceles triangle, the sides are the same and the angles are the same.
Yeah. Yeah. That's SSS. Yeah, that works. So the way ZG mentioned, that's a theorem called, that's SSS congruence. It's basically Pythagorean theorem, but since we haven't covered that yet, that's like in the future. That's in a future class. Basically, what he said, that with the Pythagorean theorem, we can say that since AM, the Pythagorean theorem is for right triangles. I'm pretty sure you guys have heard of it. It's a squared plus b squared equals c squared. And what he's mentioning is since AM equals AM, and then AB is basically a given side x y, and then since AB is given to be equal to AC, uh BM has to be equal to MC, and that's what he's mentioning. And then So this is z as well, and this is y. So if this is x, then this is x as well. Because so for Pythagorean theorem to hold, it would be like x squared plus y squared equals z squared. And since now x y x z y and x z, like since all the sides are correspondingly equal, the triangle is congruent according to SSS congruence. Yeah, that's good. Yeah. Okay, so I guess we'll have time for one. Oh, let's discuss another type of triangle. I'm pretty sure you guys have heard of this as well, but they're just for. So another type of isosceles triangle is an equilateral triangle. Not very accurate drawing. ABC. An equilateral triangle, all the sides are the same. So AB equals BC equals AC. And does anyone know what the sides are? Like the angles are? They're all the same. Yeah, you can go.
For any equilateral triangle, every angle is 60 degrees.
Yeah,
Because
that's
60
good.
multiplied by 3 is 180. The
Yeah,
sum.
yeah, exactly. So in an equilateral triangle, right? All of the angles have to be equal to each other because the sides opposite to those angles are equal to each other. So 3x equals 180 or x equals 60. So this will be 60, this will be 60, and so on. Yeah, that's good. And I guess we have time for one more problem before we end the class today. So we'll go over this problem. So wait, sorry. So we have something like this. A, B, C, D, and right, and then so what's angle PBD? Angle P, we want angle PBD. So since some of you guys got it, yeah, that's right. Since some of you guys got it, we'll just go over the solution. Basically, what you can do is you can draw a line like right here. This is a diagonal, by the way, as we discussed. We can draw a line like that. And since triangle APB is given to be equilateral, this angle is 60 degrees. 60 degrees, and the diagonal in a square splits these angles in half. Or you could have just noticed that these angles have to be angle ABD equals angle DBC because of SSS. So AB equals DC BC, sorry. Yeah, DC, sorry. Yeah. And then AD equals BC, and then BD is just equal to BD. So SSS says that the triangles are congruent, ABD and BDC. And then, so basically, then these two angles are equal to each other. And since this was given to be right, or like 90 degrees, you could have just, so angle ABD, right? Angle ABD is just 45 degrees. So add that to the 60 and you get 105. Yeah. And that's all we have time for today. Now, you guys are free to go. And if you guys have any questions, you guys can email me. And homework will be posted tomorrow or in a short while. And I will also post these notes so that you guys have time to review them and find and use them to your good use. Yeah, and yeah, you guys are free to go now.